Myself, Madhuri Modak, Assistant Professor in Mathematics, Department of Computer Science, Abhidanandar Senior College. Discrete mathematics is very important for students of computer science. Now here we start with unit number 3, Techniques of Counting of Discrete Mathematics. Now the next point is Pigeonhole Principle. See the statement. If k is a positive integer and k plus 1 or more objects or pigeons are placed into k boxes or holes, then there is at least one box or hole containing two or more of the objects, that is, pigeons. This principle was first stated by German mathematician Dirichlet. Hence, it is also called as Dirichlet-Brouwer principle. Now, see what is actually a statement. K is any natural number, means positive integers. So if more than k means k plus 1 or more objects are placed into k boxes, then definitely there is at least one box containing two or more than that objects. For example, suppose there are 5 boxes and there are 6 objects. Now we want to put 6 objects into that 5 boxes. So we can keep all the 6 objects in single box or we can divide them in different box. Now in extreme case, even though we are putting one object in one box, then 5 objects will be kept in 5 boxes. But there is one object remaining which we have to place in one of the boxes only. So that box will contain 2 objects. So here we have taken 5 boxes and 6 objects. So number of objects are more than number of boxes. So we got one box containing 2 objects minimum. So this is nothing but the pigeonhole principle. Now see first example. Show that in a group of 13 people there must be at least 2 having birthday in the same month. See, we have considered any group of 13 people. Now how many months are there in a year? There are 12 months from January to December. So what actually we are doing here? So we consider the birth month of every person in that group. Now as there are 12 months in a year, we form 12 boxes. One box of January, one of February, like that, and last box will be of December. So the person whose birthday is in January will go to January box. Whose birthday is in February will go to February box. So in this way, for 13 persons, there will be 13 months, but actual different months are 12 in number. So definitely one month will contain at least 2 persons, and it means there must exist at least 2 persons whose birthday will fall in the same month. So here we have used pigeonhole principle. So actually 13 people are nothing but the objects that we are putting in 12 months, which are nothing but 12 boxes. Now see second example. Show that if there are 30 students in a class, then at least 2 have last names that begin with the same letter. Now see how many letters are there? 26 letters are there, A to Z. Now as there are 30 students, they have 30 last names. So we are considering 30 students as the objects and 26 letters, namely A to Z, are the boxes. Now the student whose last name begins with A will go to box A. The student whose last name will begin with B will go to box B. So in this way, boxes are only 26 because there are 26 letters, but there are 30 students, means 30 objects. So number of objects are more than number of boxes. So by pigeonhole principle, at least 2 students must belong to the same class. That is, at least 2 have last names that begin with the same letter. So it may be possible that all 30 students have last name is starting with the same letter. So they will go in the same box. Then in that case, that box will contain at least 2 students having same last name letter. Now see third example. How many students do you need in a school to guarantee that there are at least 2 students who have the same first 2 initials? Now this question is quite different from previous one. In previous 2 examples, We have proved it by using pigeonhole principle. Now in this case we have to find the number of objects, that minimum number of objects we should take, so that in a school at least two students have same first two initials. Now uh, initial of every student will be from A to Z. Now first initial has 26 ways, that is A to Z. Now second initial is again from A to Z because it may be repeated also. So how many ways first two initials can be formed, like A B, A C, like that. So by product rule there are 26 into 26, that is 676 different possible sets of first two initials. So A B, A Z, then B Z, like that. There are 676 possible sets of first two initials. So we consider the 676 as 676 boxes. Now to apply the pigeonhole principle, number of objects must be greater than number of boxes. Now here we are putting the students according to their first two initial, and so number of objects must be greater than 676. It means it is at least 677. So if we consider a group of students which contains minimum 677 students, then definitely there exist at least two students who have same first two initials. Now see next example. From any set of 13 integers, prove that there will be at least one pair which leaves the same remainder when divided by 12. So here we are considering any set of 13 integers, means we are randomly taking 13 integers. Now we have to show that there is a pair. It means there are at least two integers which leave the same remainder when divided by 12. Now first see one thing, that if you divide any integer by 12, then the values of remainder that we get are 0, 1, 2 up to 11. So we consider S as 0, 1 to 11, that is set of remainders when an integer is divided by 12. Now there are 13 integers. We divide each integer by 12. So if any integer when divided by 12, the remainder is 0, then it will go to the box 0. If the remainder is 1, then it will go to box 1. So in this way, these 12 remainder values are 12 boxes, and there are 13 integers which are objects in this case. So by pigeonhole principle, there is a pair of integers which will belong to the same box. It means they leave the same remainder when divided by 12. Now next example, show that if any 7 numbers from 1 to 12 are chosen, then 2 of them will add to 13. Now here we are continuously taking numbers from 1 to 12, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now from that 1 to 12 numbers, you have to select any 7 numbers, but by randomly selecting any 7 numbers each time, we definitely get one pair whose addition is equal to 13. Now here are forming some boxes. See how we are forming the boxes. We form the box containing two numbers from 1 to 12 whose addition is equal to 13. So first box is B1 which contains 112. So here we are selecting first number and last number because their addition is 13. Now second box is nothing but second number and second last number, that is 211. And in the same way B3 is 310, B4 is 49, B5 is 58, B6 is 67. Now after that, if I am trying to form B7, it will be 76, which is same as B6. So these are the 6 different boxes where in each box sum of the two integers is equal to 13. Now, if you observe all the 6 boxes, it contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Means union of all these boxes is nothing but 1 to 12. It means all the 1 to 12 numbers are covered in these 6 boxes. Now, from 1 to 12, we are selecting 7 numbers. So selecting 7 numbers from 1 to 12 is nothing but selecting 7 numbers from these 6 boxes only. So from one box, suppose we have selected one number. So in this way we will get 6 numbers. But actually we have to select 7 numbers. So one of the box must be repeated. It means we have to select 2 numbers from one box. And if we are selecting 2 numbers from one box, then it means their addition is equal to 13. Because for any 2 numbers in that box, their addition is 13. So by pigeonhole principle, if any 7 numbers from 1 to 12 are chosen, then 2 of them will add to 13. Now, next example is geometric type example. Prove that of any 5 points chosen within an equilateral triangle of side length 1, there are 2 whose distance apart is at most 1 by 2. Now here we have to do some construction, then only we can apply pigeonhole principle. Now first see what is equilateral triangle. So equilateral triangle is a triangle having all three sides of equal length. So here we have given that the triangle has side length 1. 1 means it is 1 unit. Now from that triangle we are selecting randomly 5 points. Now we have to show that there are 2 whose distance apart is at most 1 by 2. Now first we consider A, B, C as vertices of that equilateral triangle. As shown in figure, here we have drawn one equilateral triangle A, B, C. Now we consider their midpoints. So we consider P, Q, R as midpoints of AB, BC, CA respectively. See, P is midpoint of AB, Q is midpoint of BC and R is midpoint of AC. So as it is a midpoint, it divides each side into two equal parts. So as AB, this is side length 1, but at midpoint we get AP and PB each of length 1 by 2. Same way Q is a midpoint of BC, so the length of PQ and length of QC is same, that is half. And same way here AR and RC each has length 1 by 2. Now see, we join these midpoints to get 4 equilateral triangles of side 1 by 2. Now after considering the midpoints PQR, we have joined PR, RQ and PQ. So the triangle ABC is now divided into 4 equilateral triangles. One is APR, then PQR, then PBQ and then QRC. So whole triangle is divided into 4 equilateral triangles. Now from this equilateral triangle ABC, we have to select 5 points. Now selecting 5 points from triangle ABC is nothing but selecting 5 points from these 4 equilateral triangles. So there are 4 triangles and we are selecting 5 points. So by pigeonhole principle, at least one triangle will have 2 points. So it may be this triangle or this triangle or this one, but all are same because each has side length 1 by 2. And so if 2 points we are getting in the same equilateral triangle of side length 1 by 2, then there is a pair of points whose distance apart is at most 1 by 2.